Now we're going to talk about the function fzero, and we're going to start by looking at the syntax where we pass in a function handle and a guess for the zero or root of the function. Okay, but let's just type a few notes here about the fzero function. So fzero tries to find a zero or root of a function represented by function handle, a function handle in this case with the name function underscore handle, near the guess, and that's going to be a scalar value. Alright, so the syntax is you call fzero, you pass it the function handle, you pass it a scalar guess, and then it will do its best to return to you the root or zero of that function near your guess. So it's a function, right? So we need to pass it a function handle. So let's go ahead and create our anonymous function again. So I'm just going to come up here and copy this code and put it down here for our use. So we're going to clear CLC, close all. We're creating our function handle. So again, at and the input variable and then the expression. We can call fplot to plot the function. And now let's actually run that and look at the plot. Okay, so one of the roots or one of the values of x that gives us a y value of 0 is -1. Okay, so this is a simple function, so that's pretty easy to figure out. So let's call fzero with some guess and see if it gives us that the root is -1. Okay, so call fzero, pass it a non-fun handle, and then a guess. So let's guess 0. Alright, and we better assign the output. So we'll say root 1 is equal to fzero, passing in a non-fun handle, and 0. Okay, so let's go ahead and run this section. So there's our plot, and it tells us that root 1 is -1. Okay, now there's another root for x equals 2. Alright, so let's try root 2 is equal to fzero, a non-fun handle, and let's guess 3. Okay, so if we guess 3, we get root 2 is equal to 2. Alright, now for fun, let's guess something in between. So root 3 is equal to, well, there aren't 3 roots, but I need a new variable name. So root 3, we'll call fzero, pass in a non-fun handle, and then let's guess, well, right in between those two would be 1.5. Okay, so run section, and root 3 is also the 2. Alright, so let's keep trying and see if we can figure out where it transitions to the -1. Maybe I better do some copying and pasting so we're not doing so much typing. Alright, let's try 1. Run section. Oh, I still get the 2. Let's try root 5. Let's try 0.5. And there I get the -1. Okay? So the point is that which root you get depends on your guess. And you need to make kind of a decent guess. I don't know if we could force it to error. Let's make a really lousy guess. So let's say fzero, a non-fun handle, and let's guess like 100 and see if it gets mad at us. Okay, so outrageous guess, and it says it's aborting its search, so it's giving up. It can't find anything with that as the initial guess. Alright, so the point here would be that you need to make a reasonable guess. Okay, perfect. Now there's one other thing that you should know, and that is that fzero is overloaded, so that if you ask for a second output, it will give you first the root and then the function value at the root. So basically it's gonna pass the root to the function and then tell you what the function evaluates to, and that should be 0, right? Because it's a root, that's the whole point. So let's give it a try. So we can ask for 2 outputs, so we'll say root and what do we want to call this? I guess we'll call it y at root, and then we will call fzero and pass in our non-fun handle and a guess of 3. Run section, and now it tells us for our guess of 3, the root is 2, and the y at that root is 0. Okay, so it did a perfect job. That root actually evaluates to a value of y equals 0, which is exactly what we would expect.